Good afternoon. Welcome at our orcharhino webinar. My name is Fabrice Mule. I'm an IT consultant with ATIX. Normally, I work with server automation, which mainly means orcharhino and config management, so Puppet and SaltStack. And today I will present you the newest feature of orcharhino in version 6.0. Let's first talk a bit about automation as a general. So automation can be done on very many levels in the data center. So you can, for example, administer your container infrastructure as, for example, Docker, Red Hat OpenShift, Rancher, and so on, and Kubernetes. You can run just plain config management and with Puppet and SaltStack. But today our main issue is how to automate the server lifecycle. So this means deployment, configuration, release management. So now the first question might be, why do we need to automate it all? So let's think. So thinking about the early 70s, when computers were huge machines, just a single computer in a data center. So configuring it was quite easy because you had to configure just one machine and it was done. So now the number of machines increased, they got smaller, faster, and more. So starting with dozens, now a couple of hundreds. And today, it's quite common that you can have up to several thousand servers in a data center. So suppose you have to deploy or manage and configure a bunch of computers, something like 10, 20 servers, and you have to do it manually. So you do it one by one. So this takes time, a lot of time. And it's very repetitive. So you have to do over and over the main steps. And after 5 or 6 servers, you might make a small mistake. And when the 7th server has a bit more of RAM or a smaller hard disk or something else. So you would like to have 10 identical servers, not 7 and 3 different ones. So automation increased stability because everything has been written down and you can achieve reproducibility without any errors. So you get stable, you get reproducible, and you got faster. You can use it to orchestrate your services. So you can define all the services require, you write down the code, and you can just provide it everywhere. And last but not least, you can enable self-service. So suppose you have developers who are having their test machines, writing the code, writing the packages, testing something, and then a machine breaks. So they need a new machine. With automation, they maybe have to open a ticket, a new machine has to be ordered, has to be deployed, and everything, which can take several hours to days, depending on the administration. With orcharhino, you can enable self-service. So you can provide certain rights and roles to your server, to your users, and then the developer can just provide his own machine after his old one has broken. So, what are we providing with ATIX? So basically, we support every enterprise Linux operating system like Red Hat and SUSE, but also others as Debian, CentOS, Ubuntu, and also the deployment of Windows servers. As configuration management tools, we support Puppet, Ansible, and SaltStack. We can deploy servers on different hypervisors like VMware, KVM, Proxmox, or also in the cloud, for example, the Google Cloud Platform, Amazon Web Services, and Microsoft Azure. Our consulting department normally gets to the customer who's interested in buying orcharhino, and we can just give advice. So as we have seen many different plugins, we know how to tell which one is the most benefit for the customer, so we can advise a customer how to actually set up the environment. Our engineering department basically develops orcharhino, so we backport errors from upstream versions of Foreman. We develop new plugins, as for example, the snapshot plugin for VMware and for Proxmox. And as an enterprise solution, we of course also provide support. The most basic one being ticket-based support. So if something breaks, something has a problem, customers can open a ticket and the support will have a look on it and fix that, up to 24/7 support if required, or we can even run the whole Orcharhino infrastructure if desired. So the basic idea of Orcharhino is to map the lifecycle, starting with deployment, running configuration management, and release management. So the first part, deployment, there's several possibilities to deploy a machine. You can do an image-based deployment, which basically means you have a template, for a VM template. In the cloud, it's the only possible way, but also on VMware and other hypervisors, you can create a VMware template. This template is being cloned. The clone comes online and will be configured, either by user data with cloud in it, or via finished template connecting the SSH. After that, your host comes online with as configured and running base configuration. A second way to deploy would be deploy a machine from scratch. In case you have a DHCP, you can use the so-called network-based deployment. In that case, your DHCP provides a network configuration for your server. The server comes online, gets the provisioning template, kickstart in case of Red Hat-based systems, preseed in case of Ubuntu Debian-based systems, and auto-yast in case of SUSE. So the provisioning template basically is just the list of commands which are executed to install your basis operating system. And again, we end up with a new host with base OS and base configuration. In case you do not have a DHCP, there's the approach of so-called boot disk-based deployment. In this case, a so-called boot disk ISO will be created. It will be uploaded to VMware, for example, will be attached to your server. The server then boots from the boot disk, gets its configuration from there, and will start installing from the provisioning template as it did before in the case of network-based deployment. In case of bare metal machines, there's also the approach of so-called discovery-based deployment. In this case, the discovery plugin is installed, and it checks actually certain subnets which are configured to be checked by the discovery server. So any server which comes online in a configured subnet, which is not known by Orcharhino or something else, will by default boot with a so-called discovery ISO. The discovery ISO will collect all the facts which are required for the server. The facts will be sent to Orcharhino, and then the host will show up in Orcharhino as so-called discovered host. From there you can just configure the host as you did before in a general provisioning and continue a provisioning for the host from this step. If you provide certain discovery rules based on hardware facts, for example, you can also automate the provisioning in that sense that if a discovery rule is met, automatically a pre-configured provisioning will be executed. As I said, we support, for example, VMware, Proxmox, Overt, KVM for normal hypervisors and also cloud platforms. So next step we are looking at is release management. So we would like to have certain version control over our packages and the content which is provided. We can do that by synchronizing upstream repositories to Orcharhino. In addition, we are able to provide security errata for operating systems where they are not available from upstream. So in general, security errata are only available for enterprise systems as Red Hat, Oracle, SLAS. We also provide them for CentOS 7, for example. Ubuntu and Debian do not even know the concept of errata by default. So we created an errata parser, which is parsing email lists for Debian and Ubuntu and also cross-checking with security repositories. And so we are able to ingest security errata information also for Debian and Ubuntu. So to get version control, we are able to freeze certain package states. So we can create so-called content views. We add the repositories to content views, and then we can publish a version. By publishing a version, the package state of this repository will be frozen to the moment the package or the repository has been frozen. And in case we need in 1 month, half a year from now, exactly the same package versions as today, we can just assign the content version which has been published today, and we will get an identical server. So Configuration is now the last step. So the first part of configuration we already saw when the host was being provisioned. So basically, the provisioning templates are a sort of configuration. Then, of course, the normal config management tools as Puppet, Ansible, and SaltStack, which are following different philosophies. Puppet being a server-client system. So you have a Puppet master where the Puppet server is running, and you have an agent running on your clients. And in regular periods, normally every half hour, the Puppet agent inquires the configuration of a Puppet master. In case it differs, the configuration will be corrected and adjusted so it matches the master. In case it's already fine, Puppet does what it does the most, it just does nothing. So as default, Orcharhino or an Orcharhino proxy are Puppet master, but of course it's also possible to configure an external Puppet master and just to forward Puppet reports and facts. Ansible is slightly different. It follows the fire and forget principle. So in this case, you have your configuration in YAML files, Ginger files, and so on, and you push your configuration via SSH to your servers. SaltStack is a hybrid compared to the first two. So you can run it in push version. So again, using a salt master and salt minions on your clients and running in the same mode as Puppet. But you can also, sorry, it was a pull mode. You can also push your configuration via SSH as you did it with Ansible. So with our config management tools, we also can configure so-called OpenSCAP policies. In this way, we can adjust certain policies and content and check if servers are compliant, and also get a report in what sense they are not compliant and what needs to be fixed to make them compliant. And last but not least, it's also possible to run certain job templates on our host. So job templates are basically scripts. These can be simple shell scripts or also Ansible scripts, which then are just pushed to our service. So let's now talk a bit about the origins of Orcharhino. So basically, Orcharhino is based on the open source project called Foreman and the plugin Cartello, which is this will be important when we are talking about Orcharhino 6.0 because of the changes. So as I said, we support Ansible, SaltStack, and Puppet as configuration management tools with an engineering and QA, making sure that our released versions are stable. So we test every version before we release them. We implement bug fixes and also new features. We provide errata for non-enterprise systems. Of course, we also provide the templates and clients which are necessary to provision a new host, to deploy a new host, and to actually subscribe it to Orcharhino so that the repositories can be assigned. We have a support, as I said, starting quite basic with a normal ticket-based support, but also can run the whole infrastructure if desired. And with a consulting, which basically gives advice on how the infrastructure can be set up. In addition, from consulting, we create a training. So in general, every customer who has acquired Orcharhino can order a training to learn how to actually use Orcharhino and get the best benefit of that. And normally this training is done by a consultant. And so you are shown how to best use Orcharhino to make it work fine. So now we are at the end of our first presentation. In case you have any questions, we have a chat function here. So just type in your question. I will have a look at it and get to that. Otherwise, I will just now switch over to our live demonstration. So let's change the share. So now you can see the host page of our demo Orcharhino. So you see here we support basically every Linux operating system, starting with Alma, CentOS, Debian, Oracle, Red Hat, Rocky, SLES, Ubuntu, and Windows. The newest feature you can see here already is that we also support now deployment of Ubuntu 22. You see a slight teaser, which is already working here. Officially, it's not supported yet, but it can be made working with Orcharhino 6.0, as you can see here. Officially, it will be working in Orcharhino 6.1. This is basically Enterprise Linux 9. So you can see here we have Alma 9, RHEL 9, Oracle 9, and Rocky Linux 9, as well as /15 SP4. So let's start with quite a generic task to show you how easy it is to deploy actually a host. So now we have here our button, Create Host. You just click on it. Now we have a name we can provide. So we have render names here, but of course we can override it and provide as name we would like to have. So let's call it webinar demo with an organization location. And now we have our host group. A host group basically is a template providing all the parameters which are required to deploy a host. If you predefine everything, you could see, now let's just deploy a CentOS 7 host because it's quite quick. And you will see that everything will be pre-filled out. I will go through the parameters a bit later so we understand how it works. But now you can see that everything has been configured already. And now we click on Submit. And our host is on the run. So let's have a first short look here on the host page. So you can see here with the status, which is okay, build status still pending, and then we receive basic facts like domain, IP address, sort master, MAC address, Puppet environment, and so on. So while the host is deploying, let's address on the most important features which have changed from Orcharhino 5.12 to Orcharhino 6.0. So the basic difference, or the most evident difference, is that until Orcharhino 5.12, Orcharhino was, as I said, Orcharhino is based on the format Cartello. It was using the Cartello plugin in the version 3.18. Cartello 3 was based on Pulp2, which means that the complete content and all the packages were stored inside a MongoDB. This has changed when upgrading to Orcharhino 6.0. Orcharhino 6.0 now uses Cartello 4.1, which is based on Pulp3. So Pulp3 no longer uses a MongoDB, but all the content and all the packages are now actually stored in a PostgreSQL. So this means when upgrading from Orcharhino 5.12 to 6.0, it's a slightly more sophisticated way how this has to be achieved, because Cartello 4.1 no longer supports Pulp2. So this means when you plan to upgrade your Orcharhino to 6.0, the first step will be to trigger a Pulp2 to 3 migration. Depending on the content, on the amount of the content and the speed of infrastructure, this is something which can take several hours up to several days. So basically, it's best to open that in the screen, you start triggering the migration, and you let it run. Once it has run through, actually you can start triggering the upgrade. So it took us quite some time to stabilize the migration. So this is the reason why we had so many minor versions of Orcharhino 5, because it's a quite difficult task, which now finally stable, which is why we finally released Orcharhino 6.0. So during this upgrade, then the final migration run will be done, making sure that all the packages have been migrated from Pulp2 to Pulp3. As we are making sure that everything will be done by hard linking, we are safe. So when we no content duplicated, so we don't need additional space, but we are fine with what we have. Then the so-called switch over will occur. So it means Pulp3 will be activated, and then the upgrade will be executed automatically. After the upgrade, when Orcharhino 6.0 comes online, Pulp3 is running, you can make your final checks, and then actually you can get rid of the MongoDB and just remove all the Pulp2 content and the MongoDB. And after cleaning up Pulp2 content, you will even have more disk space left as before beginning of the migration. So let's have a look on how such a repository looks like in Pulp3. So the difference is not that big. It's mainly under the hood. So you won't notice a too big difference when looking inside the graphic user interface. So let's open two products or two repositories, one RPM-based one and one Debian-based one. So let's have a look on here, on Alma Linux, for example, the upstream, and for Debian 10, the bus domain. So you see here now we look more similar than before. So basically we provide here just an upstream URL. We verify if we want to check SSL. We provide the YAM metadata. And now we have additional mirroring policies. So the download policy here is basically the same. So on demand and immediate. And the mirroring policy is now slightly changed, as now we can provide additional additive content only and complete mirroring, which means that we can make sure that upstream repositories which are gone are also gone on Orcharhino. This worked already before, but we also can make sure that this is done with metadata. So now we got the same mirroring policies and download policies for Debian repositories, which is a new feature for Debian, which didn't exist before. And last but not least, as I mentioned before, the download policy on demand. Technically, it was already available for SUSE repositories before, but it was not functional and was not supported. Now this officially works. Another change which came with Orcharhino 6.0 is how Orcharhino proxies are being used. So let's go to our infrastructure and have a look on our Orcharhino proxies. For those of you who are not familiar with Orcharhino proxies, the basic idea is the following. If you have certain networks where, for example, at DMZ, where Orcharhino is not supposed to connect directly to your servers because it's just a closed network, there are two possibilities, of course. So suppose you have 100 servers in your DMZ and you have one Orcharhino, and the firewall is closed. Possibility number one, you make 100 firewall exceptions for Orcharhino to connect to your servers. Of course, that's not really feasible. Possibility number two, you create an Orcharhino proxy, which is just a host which provides all the tasks, all the services which are required for servers inside the DMZ. And then you open a firewall exception just between Orcharhino and its proxy. So you have only one exception, not 100. And then Orcharhino proxy is a server which administers all your hosts in there. We had proxies in two flavors. One called a pulp proxy. In this case, the complete content was being mirrored on the proxy. And the service requested the packages from the proxy and got them from there. A second one we called squid proxy. In this case, there was a squid service running on the proxy, and the servers were requiring the packages from Orcharhino directly, but were told to run over the proxy using squid in the port 3122. So the second scenario was one scenario which was valid until Orcharhino 5.12. This one has changed with upgrading to Orcharhino 6.0. So let's have a look on our proxy in this environment. So you will see here our proxy demo DMZ ATIX used to be a squid proxy. Now, if we go to edit, we can see that our policy has changed. So what I mentioned before, a pulp proxy, which is providing the packages completely and mirroring everything, uses the download policy immediate. So every assigned lifecycle will be automatically synchronized to a proxy and can be provided to the service. In this case, we have a streamed proxy. So this means that the packages which are provided by Orcharhino will be not stored on the proxy. So this makes sense in case you have everything in one data center and you don't want to have multiple mirrors to space, but you just want to provide the content. In this case, the stream policy makes sure that on the proxy only the metadata will be created. And then when a client server inquires a package, it asks the proxy will download it from Orcharhino, provide it to the server without caching it. So basically we have the same functionality as before without having to make use of the squid service. And now everything is more symmetric compared to the pulp proxy. So now let's have a look if our server already is deployed. Otherwise, we can have a look on an already existing server, what we can actually see. So apparently our server is still deploying. So let's have a look on a server which we already have. So let's have a look on our CentOS 7 server. So where is it? Here it is. So we see it's red. So our status is error. What does this mean? Why is our host in error status? So the status here is just a summary of all statuses you can see here below. So if we look down here in red, we can see actually we have an error status because we have security errata installable. In our case, this is something we do on purpose because this puts us into a situation where we can easily show how a patch can be applied. So we see here the compliance, so this was an open SCAP, so this host is compliant, it's installed without a problem. Configuration just tells us the status of the last configuration manager in the run, so this would be Ansible, Puppet, or SaltStack. No changes means the last run was successfully and didn't change anything. This is quite normal if you have already several Puppet runs because then everything's already configured correctly. We see here execution state, last execution succeeded. So for example, an Ansible run or an attack command which was sent to the client server or a job template. So this worked fine. We see here again, as I said, we have security errata with a system purpose which has been specified, and the host is fully subscribed. And the traces tell us if a package upgrade required a reboot or a restart of the service. So now let's have a look on the content we're actually providing. We can do that by clicking here on the content button. So here we have our details page. We have a rough summary of all our facts. We see the UID and so on. On the right side, we already see that we have several security errata, 43 security errata, 52 bug fixes, and 3 enhancements. Here we actually see the content which was assigned to our server. So we see this is a testing server, so you can provide several lifecycle environments. In our case, we have just a generic development, testing, production, but it's also possible to create lifecycles based on time, for example, Q1, 2021, Q2, Q3, and Q4, and just move your server from one status to the other. So now we also have our assigned content view. So basically here we have our frozen packages. So this is defined by the packages we have frozen, and the lifecycle actually defines us which version of the content view is to be used. So let's have a look on the packages we have on our client server. So we go to packages and we click on installed. So now what we see is a list of all packages which are installed on the server, also showing the version which are installed. If we go to actions, actually you can here now select between package install, package update, and package remove. We can just type in a name and then just via remote execution install, update, or remove a package. So let's have a look if htop is installed. So we had here our list of installed packages. I type in htop, click on search, and apparently we have htop installed. So let's just remove htop. So we connect to orcharhino, we choose package remove, htop, perform, and now a remote execution has been triggered towards our client server. When we click here on the client name, actually we can see what happens on the shell. So we see here the yum action is being run, and we can see it's erasing htop. Access status was 0, so it was successful. Everything is green. We go back here. We refresh our package page. Wait, here installed. We look for htop. Htop is gone. In the same way, we can just reinstall htop. Totally done. Perform. And we actually let it run because we know that it works. So now let's have a look here on the section applicable. Applicable gives us a list of all package updates which are available on orcharhino for this server. So let's wait a second. So for example, we can see here we have bash version 4.2.46. So this means we have Bash already installed on the client server, but in an older version. And by just checking here and a different tool and choose upgrade, we can just upgrade the package to a new version and everything is fine. But now let's have actually a look on how we can patch our service. So we go here to our errata list. So now here we have a list of all the errata which are open on our server. So for those of you who are not familiar with the concept of an erratum basically tells you if there is an issue open on the server. We can have a look on one of the errata, and actually we see a description, what this erratum is about, when it has been issued, and actually we see which packages are affected and to which package version the packages need to be updated to close the issue. So now we have here a kernel erratum. So let's apply the kernel erratum once the page has reloaded. We check here, we apply selected and apply. So actually, if we can now click here on preview templates, you can see this is actually the script which is being applied on the server. So this is just a yum update minimal of the advisory. So basically the erratum we selected. So now let's have a look on our client server over here and see what it's telling us. So it's determining the fastest mirror. Apparently now it's taking a bit longer to install. Now it got the kernel. We let it run. If it takes too long, we will just let it run and we can have an additional look on the content. So let's have a look on the content while this one is applying. Or is it's almost done? Doesn't matter. So we have a look on it afterwards. So let's now have a look on the content. I already showed you the products, how they are being created. Now let's have a look on the content views. So actually there are two concepts of content views. One is quite generic. So you create a content view and then you just add certain repositories. Now let's have a look on CentOS 7. We can see here, if we go to, you can choose between YAM content, Debian content, file repositories, and so on. Let's now have a look on YAM content because this does not make a big difference for content views. So now we added the 3 repositories. And once I click on the button, publish new version, the content view will be frozen and provide exactly the package versions which have been synchronized at the moment of publishing. So we see here we already have 2 different versions. One has been published on June 28th and one on July 6th. The second possibility to create content views is the following. So basically, if you want to update your server and provide new content, you need to publish a new content view. Now, if you want certain flexibility to update your content, for example, you have a CentOS with Puppet, and you just require a new Puppet version, but you don't want to update your operating system, then this cannot be simply done with a content view because once you publish a content view, everything will be updated. In this case, you can create 2 different content views, one just with CentOS and one with Puppet. And in case you want to just update Puppet, you just publish a new version of Puppet, and everything is fine, almost fine. So now the thing is the following. So you only can provide one content view at a time to a client server. So how can we actually then do that if we have 2 different ones? This is where composite content views come into the game. So, okay, this went through, but it's not what I want to do right now. Let's go back to our content views. So now let's have a look on one composite content view. And in a composite content view, you do not add repositories, but you add actual content views. So let's have a look on our composite CentOS 7. And if you go here to content views, you can see here we have a CentOS 7 content view, a client one, a Puppet one, SaltStack, and EPL. And in case you just want to update your Puppet content view, your Puppet content, you just publish a new version of your Puppet, and then a new version of your composite content view, so that the new version of Puppet will be part of that, and you are fine. As I said before, we have lifecycle management. So how do we actually tell a server which version of your content view is to be used. So we see here the versions. So now we see actually we have now for our Component Center 7 3 different versions, version 16, 17, and 19. And now actually all the environments are in the same production, in the same all the environments are assigned the same version. But basically, in case that version production will still be in version 17, a production server would be connected to version 17, and a testing server, for example, to version 19. And then by approaching promotion or promoting, then just version 19 would be promoted to production. So maybe let's have a look on a different content view where this is still separate so that I can just demonstrate how it actually works. So let's see if all my maybe still is in the original state. Yes. So here we have a better example. So suppose we have an Alma 8 production server. So we tell it to be connected to Alma 8. And then it will take the version which is assigned to production. So a production Alma will be connected to version 1. A test server will be connected to version 2. In case I say testing has been successful and version 2 is ready to be deployed to production servers, I just click here on promote. I select production. I click here on promote version. And then the flag production will be assigned to version 2.0. And then automatically all production servers will be connected to the newer repository version. This does not mean that the servers will be updated automatically. Updates are to be triggered when you desire it. This is nothing automatically, it's your decision. The only thing which changes is the source of truth. So now we can have a look back on our server. So we see here it ran through. So this was successful, and we go back in here. So we can have a look on our traces. And as we did a kernel update, now it is telling us that our server desires to be rebooted. So we can also have a look on our server page itself to see how it looks there. So let's wait a second until all hosts are listed again. We go here to our webinar. No, that was not webinar. We were at the Center 7 host. And you can see here it's telling us traces reboot required. So there are now several possibilities to reboot the server. Of course, you can SSH to the server and just reboot it. But this would not be really automatic or central. And a different possibility would be here to go to schedule remote job, select, for example, power, and select restart. Of course, this cannot only be done on a one-by-one base. This can be done also done as a bulk job. So any remote execution or any task you would like to do can be run on several servers simultaneously. So let's just take these 3 servers or 4 servers. We go here to select action, change power state, and here, for example, reboot, and then all servers which have been marked will be rebooted. And last but not least, because we are in there, we can also go here. We have a list of the services, in this case kernel. We just click here on kernel. We click on restart selected, and then required services will be restarted. In this case, it will trigger a reboot. So it will take about 1 minute. When the server goes down, reboots. Then it will take something like 1 to 3 minutes. The traces will be updated, and Orcharhino will be told that the server has rebooted, and it will be green again. So in the meanwhile, we have seen that our server here has deployed. If you look here now on reports, actually we can see we got an Ansible report, that Ansible has run through. We see that Puppet has run through actually twice, because the first run started during deployment, then the server went into reboot because deployment was ready and had to start, and then actually the Puppet run was finished after reboot. The third tool we can't see here yet because it's still yet to be scheduled. So let's have a look on our CentOS server. If it's configured in here, I have to check. Let's go back in the history until we go back to the host page. Oh, it's quite far. So let's wait that it reloaded. That was actually one too far. So here we are. We now go to our reports. And actually we see here that we also get regularly our salt reports. So normally Puppet and SaltStack run regularly. Ansible is configured to run as a fire and forget. By default, there is a certain timeout set in Orcharhino. Default timeout is 6 minutes, can be set to a higher value in case you make sure that the host comes online. Motivation is the following. So let's now have a look on our host group to see what we can actually provide. Because when actually deploying a host, we just picked a host group to provide all the different parameters. So we can have a look at these parameters we were actually using. So let's have a look on our CentOS host group to see what we actually made use of. So you can see here we can also at the beginning assign salt states to our host, Puppet classes, and Ansible roles. So the salt state and Puppet classes are the ones which are applied by default by the Puppet master and the salt master. Ansible, there's no Ansible master, but we assigned a role at the beginning. So this means that once the host has told Orcharhino, I'm built, I'm ready to be configured, the countdown starts. As I said, default 6 minutes. And after the 6 minutes, this role here will be automatically applied to our server, as we have seen in our test server we just deployed before. So we see here basically all the configuration. We see the lifecycle, which has been assigned to our server. So basically everything we have seen already. We have here our content view, the content source, which by default is Orcharhino, or an Orcharhino proxy in case it's connected to the proxy. Here we have the Puppet environment in case Puppet is being used. Here we have our compute resource, which could be a VMware or something else. The compute profile basically is just a template on how a server looks like. Here we provide a default amount of memory, hard disk, computer cores. Here we define our Puppet master, OpenSCAP proxy, and our salt environment. Here the network basically is defined, so domain and subnets to which the server is supposed to be installed. Here we have the parameters to configure our configuration, our operating system. So architecture, OS itself, installation medium, partition table, and Pixie loader. Here we can add actually additional parameters which are important for provisioning. So for example, here, because it's our demo environment and we want to have it outdated to apply patches, we told the server not to upgrade to the latest state. Here we provide the repository to the Orcharhino client, which is required to actually subscribe those to Orcharhino or the proxy. In our case, we made sure that just for illustration, that the firewall is offline on the server, for example. And location and organization are basically two possibilities to sort your servers. For example, if you have different data centers, you can assign them to different locations just to make sure where they are, to have an easier overview of your service. Organization is a bit stricter. For example, if you have different departments and you want to make sure that users of different departments only can access their own service and not of other departments, you can use that. And here you have an activation key, which actually tells the server which subscriptions and which repositories should be provided once it has subscribed to Orcharhino. So, as I said, different user roles. We can also now have a look finally at our user groups. So basically we have here authentication sources where you can add an LDAP server or an AD, and from there certain user groups. Of course, you can also create local user groups if you prefer that. Once you have created these user groups, you can actually assign certain roles. So basically you have here user groups of all our ATIX users who are allowed to access our demo Orcharhino. And here we actually assigned the roles. So in our case, you can see that everybody's allowed to be as an administrator. Of course, in a real productive environment, this is not feasible. And here you have plenty of default roles which already exist on the server. So we can here also have a look on administrator roles. So we have default roles here for an auditor, discovery manager, a sort admin, sort viewer, snapshot manager, many different things. In case you require a role which is not provided by default, it's quite easy to create your own role because you just can click here on create role. So like this demo role we had here before, you go here to filters, and then you can start create a new filter and just assign the rights you require for your user. So now the last part, as I said, configuration management runs quite automatic. In case you need a manual override, for example, you have changed your Ansible configuration and you want to rerun that, or you have changed your Puppet configuration and you do not want to wait that Puppet runs its regular schedule and want to apply it immediately right now, or it's a salt stack, we can now go back to our host here. We click here on remote schedule remote job. Now we can click on the arrow on the right side. So if you click here on run Ansible roles, all the roles which have been assigned to the server will be applied right now. If we click on run, a sort run will be applied right now and not wait for its next schedule. Or we can run just run a single Puppet run. So let's check what the last report was that was actually used. It was Puppet and Ansible. So we have no sort run yet. So let's actually run sort on our server. So this is going to take a few seconds. We can now have a look here on the GUI. So we see here the job has been scheduled, and now we have to wait that everything is being applied. You have many different possibilities actually to assign jobs. Okay, so you see here, we run. This was the old message of the day, which was set by Ansible and has been overwritten by SaltStack. So basically we see here what happened on the shell. This was successful. We go back to our host overview. We click here on reports. And actually now we see here we got our salt report, salt logo, everything fine, 19 seconds ago. We click on the name. And actually we see here what has been done to the server. So as I wanted to say it right now, there are plenty of things you can do with remote execution. So you have plenty of options running Ansible and so on, sort, Puppet, configurations, runs, and much more, or also just simple ad hoc commands. So let's just run an uptime towards our server. So you can just type in this command here. You click here on submit. We now click here on what it tells us. So we see what's successful, and it tells us that our host has been up for 18 minutes. So I'm basically now at the end of our demonstration. In case that there are any questions left, as I told you, there is the chat function. I will wait 1 more minute to address the questions. And if not, thank you for your participation and have a nice afternoon. Okay, there seem to be no further question. So thanks again. Have a nice afternoon and bye.